Here we are at example 5a from our 5.1 set of notes. We're asked to use the properties of exponents to actually solve for x here. Now, in just looking at a, it kind of just looks really weird because we've got like threes and a bunch of different exponents going on. But if we go back to our rules of exponents, we know that any time that we are multiplying these like bases right here on the left side, that we can go ahead and add those exponents. Now, the criteria is that these do have to match. They both match. They are 3. Such then, if we're multiplying those like bases, we can go ahead and add those two exponents together. So when we do that, we end up then with 3x plus 2 now, because again, adding those two exponents, is equal to 3 raised to the 3x minus 2. Well, now if we just kind of take a step back and look at the situation, we have this 3 raised to the x plus 2 on the left side. We also have 3 raised to the 3x minus 2 on the right side. Well, if this is in fact a true equal statement, well, we notice that the bases are exactly the same. In this case, they're both 3. Then, by the law of equations, the exponents must also be the same. If this is going to be a true equation, the bases are exactly the same already. The exponents then would have to be the same in order for this to be, again, a true statement. So in that event, we actually end up then with just taking the exponents. X plus 2 is equal to 3x minus 2. And now it's pretty much just trying to solve for x, so nothing really crazy hard, but that's how you actually go about continuing on. So we would end up maybe just subtracting x from here. I like to keep my x's positive. And then add 2 to both sides over here. So we end up with 4 on the left side equals 2x on the right. And then just divide both sides by 2. Looks like x comes out to be 2. And you can even verify this. We can actually plug this back in just to kind of make sure that things are happening the way that they should be. So in fact, we'll just show that. So we end up then with 3 raised, instead of the x, it's raised to the second power, times this 3 that we know is already squared is equal to 3 raised to the 3 times 2, again throwing that in for x, because we know it's 2, minus 2. So on the left side, multiplying with the same base, we are adding those exponents. We end up with 3 to the 4th. Equals on the right side, we have, according to PEMDAS, 3 times 2 is 6, minus 2, we end up then with 4 as well as that exponent. So we notice that it does in fact create that true statement that we were hoping for. Again, that is example 5a from our 5.1 set of notes.